Hi class, Professor Dave here, and we're going to show you how to do regression on the TI83-84 calculator. So let's do an example, casino size and revenue. Find the best predicted amount of revenue in millions of dollars of a casino with size 150,000 square feet. And we have this data. All right, we have casino size and revenue. So our null hypothesis is going to be that there is no linear fit, or the linear regression model does not hold. And we do that by saying beta is equal to 0. Because in the regression line we're going to have a plus beta times x. Okay, and if beta is equal to 0, then x doesn't help you predict y or the revenue at all. Okay, the alternative is that beta is not equal to 0, that there is a linear fit, and that the linear model does hold. So that's what we're going to test. All right, let's bring in the calculator, and we'll turn this guy on. And let's see, clear. So the first thing that we have to do is go into stats and edit. We have to enter the data. And I list the x values in L1, which are the size of the casino, and the y values or the revenue in L2. And I already done that. Next we go to stats tests, and we go up to linear regression t-test. Okay, so that's linear regression. Hit enter. Now x, the casino size, is in L1, y, the revenue, is in L2, frequency 1 for each, and then we have beta or rho. Rho is the correlation coefficient. Well, that's not equal to 0, the alternative hypothesis. So let's calculate. Go down and calculate, hit enter. Okay, we get lots of good stuff. The equation is y is equal to a plus bx, right? And we're testing whether beta is not equal to 0 or rho, the correlation coefficient, is not equal to 0. We get a t-score of 5.8. So 5.8, that's a very large z-score, really unlikely. Our p-value is 0.002, 0.002. Okay, and then we can look at the regression line. By the way, 0.002 is less than alpha, whether alpha is equal to 0.05, the default one, or 0.01, or what have you. So we can reject HO, and we can go with the alternative, so it holds. Okay, let's write the regression equation then. If we scroll down, we have a is equal to a negative 16.55, and b is equal to a 1.22. So we'll write that in. Y hat is always a predicted value in statistics. Y hat is equal to a minus 16.55 plus 1.22 times x, where x is the casino square footage. Okay, so we can use that to predict, but let's just first interpret these coefficients. The 1.22 means for every additional 1,000 square feet of space, we'll get another $1.22 million in revenue. And the coefficient here, this is really just the intercept. Sometimes it makes you can interpret it as something that makes sense. A negative here certainly doesn't make sense, but every line has to have an intercept. So it's just the intercept here. And none of our data, none of the casino size or anything anywhere near 0. So it wouldn't make sense for that to have anything. So it's just the intercept. Okay, so let's predict the revenue for a casino with 150,000 square feet of space. So we just plug that into the equation. That's what x is, and we get we would predict $166 million of revenue for that casino. Okay, now if we scroll down further on the calculator, we get our r and our r squared. So r is equal to 9.33. So 9.33 is a pretty strong positive correlation between size and revenue. Now r squared is 0.87. So r squared is 0.87, and that means that that's the coefficient of determination, and about 87% of the variation in revenue can be accounted for by the variation in size. I hope that's helpful.